Hello everyone, I'm Gyan and you are learning computer science with Python for class 11th. In this video we are going to learn about microprocessors. Microprocessors. We know that in earlier days, before invention of integrated circuit, means IC, we were using vacuum tubes to create a processing unit. But with the invention of integrated circuits, means IC, the whole processing units started to be accommodated just in one chip. A integrated circuit chip looks like this, and whole processing unit started to be accommodated on this chip. So let's see the definition of microprocessors. A processor means CPU which is implemented on a single microchip. Microchip means a single IC. Microchip means a single integrated circuit, a single IC. It's called microprocessor. Microprocessor. That means when you can accommodate a whole processing unit on a single IC, on a single microchip, then this is called microprocessor. That chip is called microprocessor. So you can say that all microprocessors are ICs, but all ICs are not microprocessors. Nowadays, almost all CPUs are microprocessors. Nowadays, almost all CPUs, all CPUs are microprocessors. Since all the CPUs are nowadays are microprocessors, so you can say a microprocessor a CPU, or you can say a CPU a microprocessor. So both the words are interchangeable nowadays. We already have learned about CPU a lot in the previous videos. But in this video, we are going to see how the microprocessor got evolved, how we started accommodating more and more transistors on a single IC to make more effective, more capable, and more strong microprocessors. So the microprocessors have evolved over time in terms of their increased processing capability, decreasing physical size, and reduced cost. So day by day, microprocessors are getting smaller in size but increasing their processing capabilities. Nowadays, currently available microprocessors are capable of processing millions of instructions per millisecond, and according to their increased processing capability, according to their decreased physical size, and according to their reduced cost, microprocessors have gone through multiple generations. As we have seen in the previous video, the IC was invented in 1970. After that, microprocessors have gone through 5 generations. So here in this video, we will look at all those 5 generations of microprocessor. So let's see generation of microprocessor. What are the various generations of microprocessor? We will see few criteria which increases or decreases with every generation of microprocessor. So first column in this table is the generation. The second column of this table is era, means in which year this generation came. The third one is chip type. We already have learned about LSI, VLSI, SLSI, etc. So what kind of chip that was in that generation? That's we are going to see here in this column. After that, the word size. I will explain what the word size is. Word size. With every generation, word size improves. So here we are going to see about the word size. I will explain it. Maximum memory size. Maximum memory size. We know that all the data and programs first should be reside in the memory to be accessed by the CPU. But what is the maximum size of memory supported by a given microprocessor? That we are going to see in this column. Then we have clock speed. Clock speed. You may not know what the clock speed is right now, but I will explain it what the clock speed is. Then we have number of cores. And finally, few famous microprocessors of that generation. So actually, the microprocessors have gone through 5 generations. First generation, then after we have second generation, after that we have third generation, then after we have fourth and fifth generations. Fourth generation and then fifth generation. So we have microprocessors from these 5 generations. The era of the first generation was from 1971 to 1973. The era of the second generation was from 1974 to 78. The era of third generation was from 1979 to 80. The era of fourth generation was from 1981 to 95. The era of fifth generation was from 1995 till date. So these were the era of various generations. Now what were the chip type? The chip type of the first generation was called LSI, means large scale integration. We have seen what is LSI in the previous video of this session. In the second generation, the chip was also called LSI. In the third and fourth generations, the chip was called VLSI, VLSI and VLSI. In the fifth generation, the chip was called SLSI. Okay, now coming to what is the word size. See, what is word size in a microprocessor? I am writing it here. Word size. A word size is maximum number of bits a microprocessor can process at a time. Maximum number of bits a microprocessor can process at a time. At a time. See, the word size depends on the size of CPU registers. You know that nowadays CPU means microprocessor and microprocessor means CPU. So the word size of the microprocessor or word size of the CPU depends on the size of registers. How much bits can be stored in a CPU register? That many bits can be processed at a time. How many bits can be stored in registers of microprocessor? That many bits can be accessed at a time. So minimum word size supported by microprocessor is 16 bits nowadays, and maximum word size supported by a microprocessor is 64 bits nowadays. In older days, microprocessors were also working on 8-bit word sizes. So hopefully you got the point what the word size is. So in the first generation of microprocessor, the word size supported was 4 or 8 bits. In the second generation, the word size supported by the microprocessors were 8 bits. In the third generation, the word size supported by the microprocessor was 16 bits. In the fourth generation, it was 32 bits. And in the fifth generation, it is 64 bits. Okay. So these many bits can be processed at a time by the CPU. Now, how much maximum memory can be supported by the microprocessors from various generations? The memory size, that means the RAM size, supported by a microprocessor depends on the word size. Memory size or RAM size supported by the microprocessor depends on the word size. Depends on the word size. If you want to calculate how the memory size is dependent on the word size, then there is a formula. I can explain the concept, but I'm not going in that details because that is not in your syllabus. But you have a formula using which you can calculate the size of memory depending on the word size. Lower the word size, lower memory will be supported by the microprocessor, and higher the word size, higher memory will be supported by the microprocessor. Okay, so the first generation was supported 1 KB of memory, just 1 KB. The second generation was supported 1 MB of memory. The third generation was supported 16 MB of memory. Fourth generation was supported 4 GB of memory, and the fifth generation was nowadays supporting almost 64 GB of memory. However, you can have more memory in the fifth generation. Okay, you can have 128 GB of memory RAM in the fifth generation microprocessors, but normally we have 64 GB of memory supported by all the fifth generation microprocessors. And when I'm saying about memory, I'm saying about RAM. After that, we have clock speed. Clock speed. Clock is an electronic circuit. It generates pulses at regular interval of time. And when a clock generates a pulse, it allows instructions to be executed in that pulse. Instructions per clock pulse can be 1 or can be less than 1. Nowadays, instruction per clock pulse can be more than 1 also. Clock is an electronic circuit which generates pulses. Clock is an electronic circuit which generates pulses. With every pulse, CPU is allowed to execute instructions, and number of instructions can be executed per clock pulse can be less than 1, can be equal to 1, or can be greater than 1. Depends on the current architecture of the microprocessor. Clock speed is number of pulses per second. It's not number of instructions per second. It's number of pulses per second. And with every pulse, few instructions are allowed to execute. Okay, depending on the architecture of microprocessor. So clock speed is number of pulses per second. Clock speed can be measured in hertz. Measured in hertz. Hz. Hopefully you know about hertz. So clock speed also measured in hertz. See, 1 hertz means 1 clock pulse per second. 2 hertz means 2 clock pulse per second. Okay. 2 gigahertz means what? 2 into 2 to the power 30 clock pulse per second. These many pulses per second. Hopefully you know about the giga, mega, etc. things. We learned about it in the previous videos. Clock pulse, so the clock speed is measured in hertz, and that hertz can be in the gigahertz, kilohertz, megahertz, etc. 2 hertz means 2 clock pulses per second, 4 hertz means 4 clock pulses per second, and 2 gigahertz means 2 into 2 to the power 30 clock pulses per second. And during every clock pulse, few instructions, either less than 1 or equal to 1 or more than 1 instructions are allowed to execute. So actually the speed of CPU is not counted in instructions per second because of some reason. We count it as clock rate, means the clock pulses per second. Therefore, in the first generation, as you can see in the first generation, the clock rate, the clock speed was 108 kilohertz to 200 kilohertz. 108 to 200 kilohertz. 200 kilohertz means what? 200 kilohertz means 200 into 2 to the power 10 pulses per second. Then in the second generation, we have up to 2 megahertz clock speed. 2 megahertz means 2 into 2 to the power 20 pulses per second. In the third generation, we have 4 megahertz to 6 megahertz of clock rate. In the fourth generation, we had up to 133 megahertz of clock rate. And in the fifth generation, we have 533 megahertz to 34 gigahertz of clock rate. 34 gigahertz of clock rate. 34 gigahertz means 34 into 2 to the power 30 clock pulses per second. Coming to number of cores. Number of cores. CORES, cores in a microprocessor. We know that microprocessors are implementation on integrated circuits, ICs. On the integrated circuits, we provide execution unit for a processor on a single microprocessor which is created on a single chip. How many computational units are present on that microprocessor is called cores of the CPU. So core is a basic computation unit of CPU. That means presence of more cores in a CPU or in a microprocessor implies more parallel execution by that CPU. That means presence of more cores in a microprocessor implies more possibilities of parallel execution. More possibilities of parallel execution. CPU is like a shop. You went for shopping and there were two shopkeepers. There were four shopkeepers. Therefore, that shop was able to entertain four customers together. In the same way, if your microprocessor has four cores, your microprocessor is able to entertain four instructions together. So, number of cores actually increases the possibility of number of parallel instructions in microprocessor. So, we had single core up to fourth generation. We had single core CPU or single core microprocessor up to fourth generation. But in the fifth generation, we got multi-core, like dual core, like quad core, octa core, etc. We got multi-core in fifth generation. Now, few famous examples of microprocessor of that era, of that generation. A famous microprocessor of the first generation is Intel 8080. Intel 8080. A famous microprocessor of the second generation is Intel 8085. Intel 8085 or Motorola 6800. 6800. Intel 8086 was a famous name of the third generation. 8086. 80386 was the famous name of the fourth generation or Motorola 68030. This was also a famous name of the fourth generation. In the fifth generation, we had Pentium, Celeron. All these microprocessors are produced by the Intel. AMD is also producing fifth generation processors. And one more thing I will write here, the core processors. Intel core processors means core i3, i5, i7. These are also fifth generation processors. So hopefully you got about the generation of microprocessors. Apart from the microprocessors, we have another concept called microcontrollers. Let's see what is the microcontroller. Microcontroller. See, microprocessor has just a processing unit on an IC chip, but microcontroller has everything on the IC chip. Okay, microcontroller has fixed amount of RAM, ROM, and other peripherals. All are embedded on the single IC chip. But the microprocessor has only a single CPU on the chip, not RAM, not ROM, and not other peripherals. So we can say that the microcontroller is a small computing device, is a small computing device which has a CPU, which has a CPU. Not only CPU, it has also a fixed amount of RAM, a fixed amount of RAM, ROM, and and other peripherals all embedded on a single chip. Means if you have whole computer system on a single chip, then that is called the microcontroller. Now the question is, what was the microprocessor then? What was the microprocessor? Microprocessor has only CPU on the chip. Microprocessor has only CPU on the chip. Microprocessor does not have the RAM, ROM or other peripherals embedded on a single chip. Now you can ask, what is the benefit of microcontrollers? Why we are going to embed everything together on a single chip? The idea is that if you want to include the benefits of computing in embedded devices, like if you want to include the benefits of computing in your air conditioning machine, AC, in your washing machine, or other stuffs at your home, in your digital camera, then in those cases, you may not require a huge amount of RAM. You may not require a huge amount of ROM. In those cases, you can embed everything together on a single chip because you require less processing power, you require less amount of RAM, less amount of ROM, and everything together can be fabricated on a single chip. Suppose that the computation power in washing machine tells that how many spins it required to wash a cloth. So such intelligence, such computation power can be harnessed by using the microcontrollers in home appliances. So hopefully you got what the microprocessor is and what is the difference between microprocessor and microcontroller. See you in next video.